Hi class, Mr. Diaz here again. We're going to cover part 2. This is number 2 on your worksheet of section 4.1. In this particular case, we're going to go over the exponent rules. Previously, we had gone over the exponential notation. So now we're going to go ahead and take a look at the actual exponent rules. So the first exponent rule that we have, and we had briefly talked about it previously, and we're going to have to go over this before we go into part 2 here, is when we have a base raised to the 0 power. So for example, if we have a raised to the 0 power, the rule states that it's going to be equal to 1. Now it doesn't matter whether it's a numeric base or an alphabetical base. If it's being raised to the 0 power, and you'll see it visibly, it'll be equal to 1. So for example, let's say you have something like 5 raised to the 0 power. Okay? So 5 raised to the 0 power will still be equal to 1. If you have something in alphabetical order or in alpha form, for example, let's take a look at, let's say you have something like this. Let's say you have y raised to 0. It'll still be equal to 1. So once again, any exponent rule, any base that's being raised to the 0 power will be equal to a 1, no matter if it's a variable or a number. The second rule that we have is, what if your base is being raised to the first power? Well, think about it. Anything that will be raised to the first power will be that base itself. So the answer for this one will be equal to a itself. So nothing changes here. Now, when you see these, when you see a variable by itself and it doesn't have an exponent, it's always understood that it is to the first power. So for example, let's say you have something like 7 raised to the first power. Right? 7 raised to the first power will still be equal to 7. Or even if you have a variable, let's say you have something like x raised to the first power. So x raised to the first power will also be equal to 1. To x, excuse me. So that'll be equal to x itself. So once again, these are your 2 basic exponent rules. We're going to be dealing with them quite a bit as we go along. Keep in mind, you probably won't see a specific example with them. It'll mainly be embedded into other types of problems that we have. So now we get to part 2 of the worksheet of section 4.1. So once again, let's take a look at that. And it's all about multiplication of bases. All right. So first, let's introduce the actual rule itself. The rule itself is called your product rule. Now, it is a type of family that we have here. So for example, if we have a base that's being multiplied by the same base, what we're going to do is we're going to keep the base and we're going to add the exponents. All right. So how does that work? And remember, this is going to be one of your major players. So let's put a double asterisk on this one, because we're going to use it quite often. So this is one of those rules that we need to memorize. Once again, this is called your product rule. All right. So let's take a look at a couple of examples that you have here. For example, let's go ahead and take a look at the very first one right there. It says letter A. It says multiply 4 raised to the second times 4 raised to the third. Okay, so we're in the second part right here. So letter A gives you 4 raised to the second times 4 raised to the third. All right, so in this particular example here, we have the bases to being the same. Both of them are 4s. So we're going to go ahead and keep them. So we're going to keep the 4, and we're going to add the exponents. 2 plus 3, that will give you 4 raised to the 5th. Now, keep in mind that in the previous section, I had told you before that we're going to simplify these things. So eventually, we are going to simplify them. In this particular case, they went ahead and kept it the same. They kept it as 4 raised to the 5th. And that is just to demonstrate this product rule. All right. But eventually, we are going to have to calculate 4 raised to the 5th. 4 times 4 times 4 times 4. Okay. So just keep that in mind. So if my math lab doesn't accept this answer, you know you're going to have to go ahead and simplify it into its numeric base. Letter B. So letter B here, we have x raised to the 8th times x raised to the 6th. All right. So in this particular case, what we're going to go ahead and do is we're going to keep the x. So the x is going to be kept, and we're going to add the exponents. A plus 6, that'll be x to the 14th. And that would be your answer right there. So there you have two examples there where you have a numeric base and you have a variable as your base, or basically a letter. But what if both of those were combined? So let's go ahead and take a look at letter C. So for letter C, and just bear with me, we have 2 p raised to the 4th and 6 p raised to the 5th. All right, so it makes it a little bit different than what we had before. Now keep in mind that this product rule, the bases have to be the same in order for you to apply this exponent rule. So we're first going to start off with the numeric ones. We have a 2 and we have a 6. Obviously, both of them are not the same. So what we're going to have to do here is we're going to have to go ahead and multiply them. 2 times 6, that'll give us 12. So in this case, we're going to go ahead and put the 12 there. And then we do have the p's the same. So p raised to the 4th times p raised to the 5th will give you p raised to the 9th. And that would be your answer for that one right there. So once again, this rule is not difficult to learn. All you have to do is just take a look at what you have there and make sure that you do the appropriate changes to it. So let's go ahead and try another one. Let's say, for example, letter E. So let me go ahead and write it down first so we could go ahead and calculate this. All right. So there we have it. We have 7x to the 4th, y to the 3rd, 3x, y to the 6th. So once again, we have 7 and 3 Obviously, they're not the same, so you're going to do the same thing that you did before. You're going to go ahead and calculate those two. So 7 times 3 will give you 21. And now we have two variables instead of one. X to the fourth, y to the third here. And we have x and y to the sixth on the second one. So what we're going to do is we first take a look. Okay, so we have x to the fourth times x. Remember what a single x represents. It means the same thing as what? Being it raised to the first power. So this will be x raised to the fifth. And if you want to put the 1, so it doesn't bother you right there, go ahead and do so. So far we have 21 x to the fifth. And then we're going to take a look at the y. So we have y to the third times y to the sixth. Once again, we use the product rule. So this will be y. And we're going to add the exponents. So 3 plus 6 will be 9. And that would be your answer right there. So once again, this stuff is not difficult. You just have to make sure that you put them in order. One other one that we do, and by the way, decimals, you do it the same way as you would do fractions, whole numbers, excuse me. So let's take a look at one with a fraction, just to make sure that we have an example like that. If you take a look at letter F, and let me go ahead and move this so we have enough space here. We have 2 raised to the third, m raised to the fourth, m raised to the 0. And then we have -3 raised to the fourth, m n to the 6. All right, so don't get intimidated by the fractions. Remember, we know how to multiply fractions. We got to reduce them diagonally or vertically first before we actually multiply them. So that's the first thing we're going to tackle. We're going to go ahead and tackle out the fractions. So we take a look at this example, and once again, this is letter F. We're going to go ahead and take a look at the diagonals. Both of them share the 3 in common. So what we're going to do is we're going to go ahead and scratch this off and reduce by 3. So it goes once here. And we're going to do the same thing here. We reduce it by 3, and it goes once there. It has not changed the value to it. It's still negative right there. The same thing with the 2 and the 4. We could reduce them. So here we could reduce the 2 by 2, so it goes once here. And 2 goes into 4 twice. Now once again, my suggestion is for you to go ahead and rewrite this so you have the appropriate fractions that you have here. Once again, make sure you put an equal sign out when you're traveling your results. So you have 1 over 1, and we have m raised to the fourth, n raised to the 0. So far we haven't done anything with the variables, so we keep them the same. Same thing with the second fraction. We have -1 over 2. And we have m. And if you want to put the 1 right there, because remember it doesn't have an exponent, go ahead and do so. And n raised to the 6. So remember how to multiply. Don't forget how to multiply fractions. You multiply 1 times 1 and 1 times 2. Remember, they're different signs, so automatically your answer will end up being negative. So your answer here will be -1/2 m raised to the fifth, because you have m raised to the fourth, times m raised to the first. And you have n raised to the 0 times n raised to the 6. So 0 plus 6 will give you 6. And that will be your answer for this one right here. All right, so this concludes the second part of section 4.1. In a minute, we'll take a look at section part 3.